So in this video, we'll see about the internal working of HashMap. It is an important topic and generally asked in the Java interviews. So I'll explain this with an example. With this example, I have taken few cases like duplicate case and few more cases, so that the working will become clear. So let's start. The definition and all you can like learn anywhere. I will explain, focus on the explaining the topic. Okay, so what happens is internally, whenever we are putting any values in the in our hash map, when we create a hash map, what it does is it creates an array. The default size is 16. So the it creates the array with index ranging from 0 to 15. So now what will happen is, firstly it will go in the first entry. When we put, like here, we in our example we are putting India comma New Delhi. So here what will happen, it will calculate hash value and index. You don't have to go into the formula like how these are calculated. You can go, like, if you have curiosity to check how this part works, but we can assume like hash is calculated and we get this value. So for I have taken few simple values. So what happens is, see, here hash is calculated, and based on this hash value we got an index from the current size of our array. Okay, so the index value we got for India is 12. So what happens is, after getting the index value, it will go to that index and it will check if that index is null or not. So initially what will happen, it will find that the index 12 is not having anything, it is null. Okay, so then what will it do, it will internally here inside the array index, the actual value is stored in a linked list node. So this is a node, particular node, and this is the structure of that node. It stores the hash, key, value, and the next node it points to. We'll get to this. Okay, so for India, what we got index 12. So it checks here, it does not found any previous value here. So what will happen, like it will simply put our node values, the calculated hash, key, and the value, and the next pointer will remain null. Okay, so our first uh, entry code saved in the hash map in this way. Okay, now the second part, the second entry, when we put, we got USA. So it calculates the hash, it calculates index. Now what will happen, it will go, we got index 1, so uh, it will go to one index, check, it will be empty at that time, so it will simply put the value here. Okay, so now this is the important part. uh, for the third part, the same thing will happen. Japan came, hash calculated, index calculated. It will go here and put the value because nothing previously is there. Now for the France, when France came, the hash calculated was same. We got this previous hash value previously also, and the index value is also same. So what will happen? Let's see. It will go to index 15. It will see it is not empty. Okay. So now what it will do? It will not simply like put in the next. It will first check. We have the key France, so it will match the current existing entries key values. So the key is uh, France we got, and here it is stored as Japan, so did not match. So it will add a new entry here and add that pointer to the next of it, and this next pointer will remain null. Okay, so this is how uh, multiple values in a single index is stored. Okay, so now after that what happened is, we got Japan again. Okay, so same procedure, hash calculated, we got an index 15 is there. What will happen, it will come to 15, previously values are there, so it will match the key. Okay, So we have the key Japan, it found Japan. So we don't need to create an new entry because the key is already present in our map. So it will just update the value. If value is also same, no change at all. If value is different, it will update the value here and simply return from here. Okay. Now for the case of next, when China came, it calculated the hash value and got the index. Now again for this case as well, we got 15 index. So what happened here, same procedure. It will come here, match the value. Japan, China did not match, next. France, China did not match, next. Now at next, there were no like nothing was present, so it will simply add a new entry here and update the pointers of this node of linked list. Okay. So this is how the put mechanism works for the hash map. Now for the get part, what happens? Get part is simple. Like we just calculate the hash values in the similar way we did previously. We got an index value. It will go to this part, whichever index we got, it will return that. If there are multiple entries, multiple nodes present in that particular bucket, like this, for the case of China, index came as 15, so it came to this particular bucket. Here multiple entries are present, so it will start iterating all the nodes present here. So it will check, it will match the key. Japan did not match, France did not match, China it matched, and it will return this value. So this is how it works. Okay. Now there are few cases. Firstly, let's check few things. Can we use a custom object as key? Yes, we can. What it means is, like currently the key which we are using is India or USA, Japan. These are string values. These are not any object like JSON object or any other kind of object. So what happens, there can be many cases like where we want to use objects for as a key reference. So we can do that simply, like we just need to uh, modify this our the definition of the map. So here whatever the structure of that map, that object is, that will come here and that will work. Okay. So can two different keys generate the exact same hash code? Yes, it can. We just saw in our example, two different keys were generating the same hash. Even it can generate the same index value as well. Okay. uh, how does HashMap handle null key? So yeah, this is a good question, like it is asked. So what happens is, in the case of null, it calculates the hash and index. So it is always stored in null in the 0th index. So null value, for the null value we get index value as 0. So that value will be stored here. And a hash map can have only one null value, one null key in the entry. It will, if we try to enter the two entries with null key, it will give us an error. Okay. So this is it. Now few things are there, like what happens, like initially our size is of 16 only. So like it's not like it will uh, all the indexes will get filled and we will keep storing in that, because you see, our cost of reading and putting is there. As this size grows, we have to for entering the new node, we need to iterate through all the nodes, and we are matching the keys. So it is a costly object, costly operation, so we cannot do it indefinitely. Okay. So what happens is, we have this load factor is there, like their default load factor is 75%. So what happens is, for the default bucket size 16, whenever the size of the bucket is 75% full. That means from the 16 size bucket, 12 is full. 12 entries are already there. So what will happen when 13th item is pushed? So what will happen is it will check, okay, the it is being crowded here. So what will it do? It will double the bucket size. So from like instead of 0 to 15, it will become 0 to 32. Okay, 31. So 32 indexes will be there. So for that, this will go on continuously. Like, but the this operation takes the time because we cannot modify this array to contain its double elements. We need to create a new array, and again all the entries which we have inserted previously are again inserted. Again hash values are calculated. Those are inserted in that in these respective buckets whichever we get from the hash. So what happens, what is done is in Java 8, this uh, important optimization was done. So in this what happens, it checks two conditions. Firstly, in a particular bucket, if there are 8 or more than 8 nodes are there, so it will not insert in that bucket. Firstly, what it will do, if there again there comes two conditions. So if what will happen, if there are the total bucket size, initial capacity, the total capacity which is there, like if it is less than 64, it will simply double it. No other things it will do. So this is a simple case. But if it reaches the 64, what happens is the linked list we are using here becomes inefficient. So for all the values, what it will do is it will replace the linked list with red black tree. You can see here. So you can search about this, understand about this in a separate video. Like our main focus is like when the data grows, it should be optimized. So for that we convert it to red black tree. Okay. So, but again, this is also taking up space, like trees take more space. So if we are deleting the entries from this, and we reach a threshold, by default it is 6. So if the number of items in the hash map becomes less than 6 or 6, so it will again convert it back to linked list instead of the tree. So that's how the working of hash maps work in Java. This is the internal working. You should know, like, it is an important topic for the interview perspective. So thank you. If you have any questions, you can ask in the comment section. Thank you, everyone.